At this point, I would like to talk about drilling and what we call fixed cycles. Up till now, we've just been essentially moving an end mill around different parts of a component that we're machining. In reality, most parts that we make, once again, will have a series of profiles that will need cutting, and they'll also have the need to take and do what we call single point machining operations. Single point machining operation would be something like a hole. So if we go back to a very basic isometric view that we've looked at in the past, we've just got a block here with a hole going through the middle of the block. And if we say that the block is 2 inches wide by 3 inches long by 1.5 inches high, and at the very center of the block we have a hole that has it's a 1/2 inch diameter hole. Okay? Our front, top, and right side views would look like this. We would have a square block. We would have a dimension here of 2 inches and a length dimension of 3 inches. And then we would show that this is in the center at 1.5 inches, and that it is 1 inch down, and that the hole is a 1/2 diameter. 1/2, and then the circle with the slash mark through it implies that it's diameter. And then of course our front view is going to look like this with the hidden lines in it. And the right side view is going to look pretty much the same with the hidden lines in it. What we want to do now is do a 2-tool cutting operation on this part. Let's take an end mill and call it tool number 1 equals an end mill. I'm going to create a tool and call it tool number 5 for lack of a better number. They don't have to be used in order. And tool number 5 is going to be a drill, to simply drill this hole. Now you remember from our discussion the difference between end milling, which involves moving a tool around the profile in X and Y, versus single point operations like drilling, where we're simply moving to an X and Y location and then taking and manipulating the Z-axis to go and drill a hole using a drill. So what would the part program look like for this here? Considering that we're going to use 2 tools, what we're going to start off with, we're going to say G90, G20, and we're going to say load tool number 1 into the machine, right? So therefore we say T1, M6. And then we're going to turn on a spindle. Let's say we want to run the spindle at S500 and turn on the spindle clockwise, so it's going to be M3. And then if this is our end mill, tool 1 is our end mill, we're now going to make a move. We're going to say G00. If we want to put it over this point right here, and we'll assume that our program datum point is set right here as well. So this is the point that we've decided to make our datum for this part program. If you remember, we can pick the datum. It can be anywhere on the part. That's up to us to choose where the dimensions are derived from. But now we're going to say G00, and what we're going to do is we're going to say X0, Y0 to put it over this point right here that we've just... So now our tool is sitting up here. Now we want to kick in the offset to bring and activate tool number 1. So if you remember, I just said we're going to use G43, Z minus, and if this part is going to be 1.5 inches thick, and we say the top surface is Z0, Z minus 1.5, and then give it a feed rate of, 5.0, but we can also then say H1. So this command, T1, physically loads tool number 1 into the turret. This address, H1, takes the value that we stored with this tool and and compensates for the length of the tool. Because if we didn't call up a tool length, we would slam the spindle face and then our tool would be somehow crashed through the part. So what H1 does is it says, okay, I've got this long of a tool, so I need you to stay up this much higher. So this kicks in our tool offset for tool number 1. And then we're going to just mill around this part, let's say. So then we say G01, Y of 2.0. So that makes our move to there. And now we're going to say X 3.0, and that makes our move to there. And then back to Y0, so that makes us go there. And then back to X0, which makes us go back to 0. And then we're going to say G00, Z, and we'll pull it up and we'll say just a number like 5 inches. So what we probably want to do is we want to turn the spindle off, because tool 1 is still sitting in the spindle. If you remember, we do that with an M05. So now the spindle's off. What we could do is now call up tool number 2, which is our drill. And we're going to say, or I'm sorry, T5 is what we called it. T5 M6. So now we're loading T5 into the spindle with the tool change arm. And let's turn on the spindle speed. I'm going to say S 1200 M3. So now our spindle is running at 1200 RPM. And now I'm going to do what is called a single point drilling operation. Think about it. All we need to do to drill a hole is we need to position over the hole. The drill is already a ½ inch, so we don't need to do circular interpolation. We simply need to go down with the drill and then come back out of the piece, and we're finished. So a couple things that we're going to consider is that we want to bring the drill down just slightly above where the hole, where the top surface of the part is. So we want to bring this to about 0.1 of an inch, let's say, above the top surface of our part. The drill is turning. And then we want to take at a feed rate and take the drill and drill through the entirety of the part, dropping below it maybe about 1/4 inch deeper. Why? Because as you recall, our drills have a point, and we want to make sure that the hole is a ½ inch diameter all the way through. So we have to clear this drill point, this sharp point, through the part. And what we want to do, based on what you already know, how could you do this? Position, rapid, feed rate, rapid, and done. We can do it long-handed. We could do the equivalent. We could say, for instance, we now want to position over the hole. I could say G00, X 1.5, Y 1.0, right? We can go G00, get us right to that point. Then I can say Z, in other words, wrap it down to 0.1 over the part. And then I can go and say G01, Z minus 1.75 at a feed rate of 10 inches a minute. So now the drill will go down to this depth of minus 1.75. And then I can say G00, take the Z and wrap it back up to 0.1 of an inch right over the part. And then I can say G00, Z 4.0, just to bring it up, and then we can end the program, let's say. All right, look at all these moves just to drill a hole. 1 positioning, 2 positioning, a feed rate, a rapid out, and another rapid. what drilling cycles do and other single point operation cycles is they take all of this information and combine it into one simple G-code. So to do this same motion that I've just done for you long-handed with all of these blocks, what we would do is we would simply say G81. 81 is the special G-code for a drilling cycle that takes a drill, rapids to a point right above the part, and then feeds down and rapids back out of the part. I say G81, and then I can provide my X and Y locations for the hole, X 1.5, Y 1.0. And now what I'm going to say is my Z depth is minus 1.75. And I want it to go to what we call, here's a new word now, it's called the R plane. So I take the letter R and tell it 0.1 of an inch. In other words, 0.1 right over the part is where we want to wrap it to. And then I just give it a feed rate of 10. So now, all of these moves from here to here have been combined into one line. So G81 says we're about to do drilling. We're going to do a hole at X 1.5 and Y 1.0. And then we're going to feed the Z. Our final depth is minus 1.75. We want to wrap it to a plane, an R plane of 0.1 at a feed rate of 10 inches a minute. And then if we're only drilling one hole, we would say G80 and then take the Z up to 4.0 or whatever value you like to work with. What G80 does is it says, okay, stop doing drilling. Everything goes back to normal. And the neat thing about the G81 is, let's assume here for a moment that our part has two holes in it, the same diameter. And the second hole is sitting at 3.875 over in X, same distance in Y, so it's minus 1.0 in Y. Once I set up my drill cycle like I did here with all the Z and the R, all I got to do, I don't have to do anything but say X and now provide the new coordinate. 3.875, Y 1.0. I don't have to repeat this stuff because it's already been set up. So it's going to go right over to the next hole, drill down and come back out again. And it's going to do that for every set of X and Y coordinates until it sees a G80. So this is an introduction to what we call fixed cycles or canned cycles. And on page 38 of your manual, we have a number of fixed cycles that do several different things. But for right now, I would like you to become familiar with two fixed cycles. One is the G81 that we've just talked about. The other will be the G83 cycle. Now let me show you what the difference is, how G81 behaves. These are the arguments besides the X and Y that we need for G81. Here are the arguments we need for G83. If we have a part that is 1 inch, 1 1/2 inches thick, and we have to drill 4 holes 1, 2, 3, 4. Each hole is 1 inch away from its next neighbor. And our y datum, x and y datum is right here. And each hole is 2.25 up in y. They're all on the same line. And they all go through this thick piece of bar stock. And it's, well, let's just say 2 inches thick. Now, 2 inches thick of material, we can't just take a drill, depending on the kind of material, we can't just take a drill and push it straight through and then wrap it back out again. What we actually got to do is take a drill and bring it down a small amount and then pull it back out again, drill down a little further and pull it back out again, drill down a little further, pull it back out again. Why all this in and out? What that does is with deeper holes to be drilled, this is called a deep hole drilling cycle, we have to clear the chips out of the drill flutes. And we got to let the material or the drill get some coolant on it as well. So we do it in a series of small little pecks and then we come back out again. Now the movement you want to take is we want to establish an R-plane slightly above the part, so I like to use the number 0.1, that's about 1/8 of an inch. And then what we want to do is, at each time we go down, we want to take 0.2 of material before we pull back out again. So another 0.2, and another 0.2, and so on until it reaches a final depth that should probably be something like minus 2.25 to clear the tip of the drill past the material. So you would have to do a lot of calculation. You would have to divide all this up by 0.2. But the G83 drilling cycle would be really easy. For this part, the drilling cycle would simply be G83, position it over the first hole, x 1.0, y 2.25. Give it the z depth, z minus 2.25. Give it your R level, which you're familiar with from before, a starting point of R.1. And now all you need to do is add the number Q and tell it, I want it to go 200 thousandths of material before it pulls back out. So each time, cut 200 thousandths of material at a feed rate of 10 inches a minute. And now you are telling it to go down 200, come back out. Go rapid, and then another 200, come back out. Rapid back to here, go down another 200 and back out until it reaches its final depth. This is the first hole occurrence, and because we turned on the G83, all we need to do now is give it the next location, X, so that would be 2 inches, right? The original one plus another one, so that's X 2.0. And now it's going to do the same thing right here until it reaches its depth. And it'll be sitting right here, ready for another command, and now we tell it X 3.0. Now it's going to position over and it's going to do your 200 thousandths of a step each time. Wrap it back out, wait there for some instruction, and we're going to say X 4.0. Going to move over to our last hole. Start pecking, down, out, down, out, down, out. And then all you do is you say G80, give it some Z value, Z 5.0 or whatever, and you're done. Back drilling. This is an operation that simply positions over an X and Y location and does a series of Z moves based on the parameters, arguments you provide to it. We'll talk about some of these other cycles, but what I'd like you to do right now is to do what we call our fixed cycle program right here. This is page 40. Please use two tools. it's saying use a spot drill, okay, and then do a G83 drill. So what a spot drill does, if you remember back from our discussion on machining processes, spot drilling involves giving a full-size drill a little bit of a place to get started. Because what we're really doing, if we're going to drill a hole in a solid piece of metal, you have to realize that our drill is sticking out some amount from a chuck. This amount that the drill is sticking out makes it kind of prone to wobble and wander. So if you start pushing this down into a material, it's going to start drifting around like this until it, kind of grabs metal and then starts cutting. So what we tend to do before we drill with a full-size drill, we come at it with a very short and stubby little drill that is really just a short little stub sticking out, and what it does is it makes a small starter hole for a full-size drill. So now you position the full-size drill over the spot drilled location, and the spot drilled hole lets this drill get a good start to make a finished hole. So you're going